So algorithm steps for interaction method. So first step will be the number one is the input the data. As we have given the input the data in case of a Gaussian method. Similarly, we also have the input the data, input the information which we have, input the data. So what information we have? We have the line data, we have the bus data, is the type of the bus, and according to the type of the bus, if it is PQ bus, what is the value of P and Q at that bus? If it is slack bus, what is the value of B and delta at that bus? If it is PV bus, what is the value of P and D? And for the line data, what is the series impedance, what is the shunt impedance, from which bus to which bus this particular line is going on. So this type of information, and what type of accuracy we require is the observation, is the value of the epsilon. So so that we have to input. So next is we have to formulate Y bus matrix. We have the transmission line data and we can formulate the Y bus matrix. So then we have the bus data. So according to the bus data, we have to check the. First we have to start the iteration count. Iteration count A is equal to 0. Then we will increment the K. So K will become K plus 1. It is the iteration number. So after this, we have to check the type of the bus. Check type of. So we have the three types of the buses. Slack bus, no action is required. Okay. And if it is PQ bus, then we have to find the value of the. We have to for the PQ bus, calculate delta P and delta Q. And for PV bus, calculate delta P. So in the second step, we have formulated the Y bus matrix, and also we have to assume the values of the unknown variables. Assume the values of unknown variables. At PQ and PV buses. So what is the unknown variables at the PQ bus is E and delta. So we have to assume the value of E and delta for all the PQ buses, and unknown variable for PV bus is delta. E is given. V is given. So we have to assume. Then our iteration count starts here. Is the iteration number of permutations starts here. Then we are checking the type of the bus. Here we are checking whether the bus is of the PQ type or PV type. Okay. So we are calculating is the for the PQ bus we are calculating delta P and delta Q. And for the PV bus we are calculating delta P. How we are calculating this? For the PQ bus, PI and QI is given. PI and QI we can calculate using the given value of V and delta and the assumed value of the V and delta, or the calculated value of the V and the delta. So we have the value of P that is given for the PQ bus. We have the calculated value of P which we have calculated using the variable values which we have. Okay? So from that, by taking the difference of given value and the calculated value, we can find the delta P. Similarly, we can find the delta P. For the PV bus, we can calculate the delta P. So here we can check the conservation. That the largest residue value means the largest of delta P, delta Q or delta P in this case, if it is greater than epsilon, if greater than or equal to epsilon, greater than epsilon, then we have to go to check slack bus. Means if the difference which we have calculated for delta P, delta Q for PQ bus and delta P for the PV bus, and maximum value of these delta P and delta Q is greater than the epsilon, okay? Then less than or equal to epsilon, then we have reached at the sufficient accuracy. So we have found the accurate values of V and delta. So means we have to calculate the slack bus count. Otherwise, we have to calculate the Jacobian matrix elements. Okay? So we have the means earlier we have we have the delta P and delta P, delta Q. We have calculated for all the buses. Then we have to calculate H, N, J, L, and delta V. And if you are taking the normalized value, then this will be equal to divided by V. See, so we have to formulate the Jacobian matrix and calculate next step is calculate the updated value of variable. So what is the updated values? This delta will be equal to delta k plus 1 is equal to delta k plus delta k. And b k plus 1 is equal to bk plus delta v k. Okay. So we have found the updated values of the variables. Then step number 9, calculate reactor power injection at PV bus. Means QY. Calculate QY. So we have the QY equation. So using that QY equation, so we can write the calculate the reactor power injection at PV bus using QY equation. And check the QY limits. Means QY must lie between QY minimum and QY maximum. So we have calculated, we have formulated the Newtonian matrix. From that we have calculated the new values of the variables. By substituting the new values of the variable for the PV bus, calculate the reactor power injection and check the limits for the reactor power injection. If this limit is violated, means if the QY is less than QY minimum or QY is greater than QY maximum, then the limits are violated. So we have to fix. If calculated value of QY for the PV bus is less than QY minimum, then we fix the QY at that bus is equal to QY minimum. And if the calculated value of QY is greater than QY maximum, then we fix the value of QY as QY maximum. So under that case, P for the PV bus already was fixed. So Q we have fixed here. So the type of the bus will be changed. So in case of violation, of limits, fix QY and make the type of bus as PQ and go to step again 3. Go to step 3. So means we have changed the type to the PQ bus. So here where we are checking the type of the bus for all the buses, that bus will be considered as PQ bus. So we will be calculating delta P and delta Q on that bus. Otherwise, we are calculating only the delta. So again, we are calculating the Jacobian elements, new values of the variables. So this way, that this process will carry on until this value of your delta P and delta Q is reduces very less. Means the maximum of the at any bus, maximum value of this is less than or equal to epsilon. Epsilon is a value according to our accuracy we have assumed. So it can be 0.5, 0.05, 0.001 according to how much accuracy we require. So accordingly we have assumed this epsilon, and if this delta P and delta Q are less than this, then we can say we have obtained the accurate values of your V and delta for all the buses. So then we have to check the slack bus. Next means, so otherwise if you have checked it for all the buses, so next step we have to calculate the step number 11. Step number 11 is calculate slack bus power. And then calculate line flows and then stop. So these are the algorithm steps for the Newton-Raphson method. First step is input the information which we have, input the data, then formulate the Y-bus matrix based on the transmission line data, and we have to assume the unknown variables. Then our gravitation counter is starting. Okay? So initially it will be count 1, starting with when the k is 0. So this k, new k value will be equal to 0 plus 1 is 1. Okay? So k, we are starting with k is equal to 1. Then we are checking the, means we have the all buses here. So we are checking the type of the buses, which is what is the type of the bus. According to the type of the bus, for the PQ bus we are calculating the delta P and delta Q. Delta PI and QI for the PQ bus is given. PI, QI we are calculating using the value of the variable we have. So from that we can calculate the delta P and delta Q. Similarly for the PV bus, Q is not given, so we are unable to calculate delta Q. So we are calculating only the delta P. Then how much accuracy we require, we have given it in the data. And if this residue value, this is known as the residue value, and maximum of this value, if it is less than epsilon, means all values will be less than this epsilon, less than or equal to epsilon. So means we have obtained sufficient accurate values of V and delta. Then we have to go to the step to calculate the slack bus power. Means we have to go to the step 11. Here we have to go to the step. Go to step 11 to calculate slack bus power. Then, if it is not, if the delta P and delta Q is not sufficiently reduced, then we have to formulate the Jacobian matrix. We have to calculate the elements of the Jacobian matrix, and using this Jacobian matrix elements, we can find the updated values of delta and V. Okay? delta for all PQ and PV bus, and V for the PQ bus. Then for the we check for the PV bus. In the system we can have the 1 or 2 PV buses also. So for the PV bus we are calculating that the values of the QI. So we have calculated the values of the variables. So by substituting those values of the variable, we can calculate the reactor power injection for the PV bus. And if that calculated value of reactor power injection at the PV bus is violating the limits, minimum and maximum limits, then we have to fix the value of the reactor power, either on the minimum value or on the maximum value. When we fix this QI at minimum or maximum value, then the type of the bus will change and it will become the PQ bus. Okay? And then we calculate for all the until we have able at that the sufficient reduced value of delta P, delta Q for PQ bus and delta P for the PV bus. So after this we calculate the slack bus power. At the slack bus power, V and delta is given. So we need to calculate the P and Q. Similarly, now we have all the values of P and Q at all the buses, so we can calculate the line flows. And also we can calculate the line losses also. We can calculate line flows and line losses also we can calculate. And after that, we can take the sufficient values, so we will be able to what is the status of the bus. So in case of the load flow study,